Hello everyone, I am Senapati. So in previous class we have discussed how to determine water content of soil. So in this class we will determine how to determine specific gravity of soil. Okay. So as we know, the formula for specific gravity is what? Gamma S upon gamma W. So gamma is your what? Unit weight of soil. Unit weight of soil or unit weight of water for gamma W. So if we take the volume as constant for both soil and water, so we can represent the specific gravity as the ratio of mass of solid to mass of water with same volume at 4 degrees Celsius temperature. Okay, so specific gravity is denoted by what? Our capital G. Okay, specific gravity we can find out by using these methods. What? Density bottle method, pycnometer method, measuring flask method, gas jar method and shrinkage limit method. Okay, so here we have the formula. So to find out this and this, we need to use those methods. So to first we will discuss about what? Density bottle method. Okay, so in case of density bottle method, what it says, we will take this density bottle which has the capacity of what? 50 ml. 50 ml capacity density bottle with a glass topper. Okay, so it has one glass topper but it has a hole here. Okay, so this is a laboratory process. We use this method in case of laboratory. So here in case of density bottle method, only the capacity of bottle is about 50 ml. Okay, so in 50 ml of this bottle, we use 5 to 10 grams of what? Oven dried soil. So we take some amount of soil about more than 15 or 20 grams. Then we what? Oven dried it. Okay. After the process of oven drying, we use those soil samples. We use those soil samples here in case of density bottle method. Okay. We measure the amount. Then we use it here. So next is our what? We have filled it 50 ml of a bottle, filled it with 5 to 10 grams of soil, dry soil. Okay. So next what we do? Okay, here it is our what? Vacuum desiccator. Okay. So what is the work of this vacuum desiccator? It works for what? To remove the air entrant here. Okay, to remove the air entrant here, we need that vacuum desiccator. If we don't have the vacuum desiccator, so what we do? Normally we heat the bottle to remove some amount of air. Okay, but to perfectly remove air, we need to have the desiccator. Okay, next is our what? So density bottle method is useful for which type of soil? It is useful for what? Fine grained soil. Okay, fine grained soil, about 90% of fine grained soil which will be passed in 2 mm of sieve size. Okay, so in next classes we will discuss about classification of soil, but now we need to know about what is fine grained soil and coarse grained soil, because in case of water content also or in specific gravity also we used those words, fine grain, coarse grain. Okay, so if soil passed in IS classification, that is Indian Standard Classification sieve of 2 mm size, if soil passed in this sieve, then that is fine grained soil. Okay, if retain in that sieve, then that is termed as coarse grained soil. But easily if we remember, if the soil size is greater, okay, if we don't remember the particular size, soil size in greater size, those are coarse grain soil. Okay. If very small size of soil, that will termed as what? Our fine grain soil. Okay. Also, if in between coarse grain and fine grain soil, that will be termed as medium grain soil. Okay. So, what we do in this process, density bottle method, we will discuss in briefly that. Okay. Okay. So, first we do one oven drying test with what? With the empty bottle, and after oven drying process we take the value as M1. M1 is our empty density bottle. Okay. Okay. Then we do what? Here we take 5 to 10 grams of soil in it, dry soil. Okay. And name that as what? Empty bottle plus soil as what? Your M2. Empty bottle plus dry soil. Okay. Next, what we do? We fill this bottle with distilled water. Okay. We fill this bottle with distilled water up to this glass topper level. Okay. Next, we measure the weight here and term that as M3. So, our M3 will be empty bottle plus dry soil plus water. Okay. So, what do we do next? So, next we clean the bottle and again open dry the bottle. Okay. So, next we fill it with complete water only and take that as our what? M4. So, our M4 will be empty bottle plus water. Okay. Now, we have all those values M1, M2, M3, M4. Now, we will calculate our specific gravity. So, specific gravity is denoted by G. So, formula will be M2 minus M1, M2 minus M1 minus M3 minus M4. Okay. So, if we know these terms, what are M1, M2, M3, M4, then we can easily remember the formula. If we don't know what are M1, M2, M3, then we will forget the values, what we will put here, what we will put here, what we will put here. Okay. So, we need to understand these terms, how these are becoming. Okay. So, after getting the formula, as we have the values, we can put it here and get our specific gravity value. Okay. So, now going to our next method here, pycnometer method. Pycnometer method is completely similar as with what? Density bottle method, but in this method we can measure more amount of soil. Okay. We can take more amount of soil sample in pycnometer method. Okay. So, yeah, the method is completely similar to density bottle method. So, the capacity of this bottle here, this is your pycnometer and this is your glass jar. Okay, here is a what? Brass, conical brass ring, and there will be one rubber or fiber is fitted for airtight purpose. Okay, so what we do here? The formula and all those methods are completely same, but difference is one here. But we can take more amount of soil, that will be our 200 to 300 grams of oven dried sample. Okay, so also in this method the soil sample is different than density bottle method. So we can take 90% here, like medium grain soil. It is perfectly fit for medium grain soil sample of 90%, which is passing through 20 mm ISC, and for coarse grain soil it will be more than 90% passing through 40 mm ISC. Okay, here and here. So the next process is completely same for those airtight. Also we can do the similar process here also. Okay, first we take the mass of this bottle, then we put some amount of soil and take that as M2. Next we will put some water, some soil sample and butter, that we will take that as what? M3. And next bottle with water, we will take that as our M4, and the formula for this method is completely similar. Okay. So next, going to the another method is our measuring flask method. In this method also we will calculate what? G. To calculate G, we need what? Our mass of soil and what? Mass of water. So this method is completely also same as with what? Density bottle method, but we take what? It can take 250 ml or 500 ml. In case of density bottle method, we can take only 50 ml capacity bottle. Okay, but in case of measuring flask method, we can take as much as can 250 ml or 500 ml capacity bottle. Okay, so here the gradation mark is here. Okay, so and this is the stopper. We need to stop air from passing through the bottle. Okay, so here this is the adapter, fitted adapter to vacuum line for removing entrapped air. Okay, so in this method, this is completely suitable for what? Your fine grain and medium grain soil. Okay, so in this method, about 80 to 100 gram of 100 gram of soil sample we can take. Okay, so we can differentiate what? In case of first density bottle method, pygnometer method, and measuring glass method. Okay, so capacities of soil we can take in case of what? Our density bottle method is only 50 ml, and in case of pygnometer it will be what? 100 to 200 ml. In case of measuring flask method, we can take what? 80 to sorry we can take here 250 to 500. Okay. So here in case of density bottle method, we use only 50 ml and 5 to 10 gram of oven dried soil. Okay. In case of pygnometer, we take 200 to 300 grams of oven dried soil. We can write it 5 to 10 grams of soil near to 100 grams of soil, and here we can take 80 to 100 grams of soil. Okay. So these are the questions asked in your normal state level exams in short type of questions. Okay. These small values are asked in those state level exams. So next is our gas jar method. This method is not important, and also in normal college laboratories we don't use this method, but we will know about this. But here as gas jar method, that doesn't mean the jar will be filled with completely gas. No. And this method is also completely similar with another like pygnometer method. So first we will take this weight of this gas jar, then take that as M1, then fill it with some amounts of soil. Okay, and take that as M2. Next, addition of some water and take that as M3. Next, addition of water and completely filled with water up to this level in plus this jar, we will take that as M4, and then we can use the similar formula as density bottle method. Okay. Here in this method, gas jar of about 1 liter capacity. Okay. In case of density meter method, then we have the capacity of 50 ml of bottle, but here we can take 1 liter capacity bottle. Then here the rubber bong is this. Okay. So okay, here this is your rubber bong, and okay, here it is the rubber bong we use to completely remove the air present here. Okay, so we have discussed all those methods except that shrinkage limit method. Here we have discussed density bottle method, pygnometer method, measuring flask method, gas jar method, but we have not discussed about this shrinkage limit method, because it is a complete chapter. Okay, the complete chapter about shrinkage limit, we will discuss that later. So until now we have already discussed about how to determine water content and how to determine specific gravity. We have discussed all those methods we used. Okay, and we know the formula. So in next class we will solve some numericals according to this. Okay, thank you so much.